Hello all, I am Dr. Pravas. In today's class, we will discuss one more example of LR0 grammar. Okay. So in the previous class, we have also discussed about some examples of LR0 grammar, means verify the grammar is LR0 or not. Okay. So in today's class, we will also discuss one more example of LR0 grammar. See the grammar. Verify the grammar is LR0. Verify the grammar is LR0 or not. Okay, so the grammar is given e to t plus c, e to t, t to I. Okay, now we'll convert or we'll add a augmented grammar prediction in the given grammar. Okay, so say e to e prime to e, so e to t plus c, e to t, t to I, okay, 1, 2, 1, 2, 3. Just make the number 1, 2, 3. So now we'll start the DFA diagram, or we'll find the LR0 items. Now we'll find the LR0 items. See how to find the LR0 items. See here. So E prime to dot. So E prime to dot E. So find the closure of E. Closure of E is E2 dot T plus E, then E2 dot T. Then here the LR0 parser will scan T. So find the T closure. Closure of T is T2 dot I. Okay, so this is I0 state. Now we'll find the next one. This is E. It will scan E. It will scan T. Then it will scan I. So E means E prime to dot. Sorry. It will scan E here. So E dot. So here it will scan E to T. It will scan T. T means T dot plus E. It will again scan the second prediction E to T dot. Then here it will scan T to I dot. So now we just make the number. This is I1 state. This is I2 state. This is I3 state. Okay. This one is also the final state. Okay. Now we'll see. I1 state is completed. I3 state is completed. Now we'll find I2 state. So this is plus E2 T plus dot E. Now we'll find the closure of E. Closure of E is E2 dot T plus E, then E2 dot T. Then we'll find the closure of T, T2 dot I. I1, I2, I3 completed. So this is I4 state. So here, similarly, we'll find, now it will scan E, it will scan T, then it will scan I. E means E2 T plus E. Okay. Then T. T means here E2 T dot plus E. Then E2 T dot. Then here T2 I dot. We'll just make the number I4. This is I5 state. So yeah, this state is completely similar to I2. So just make the number. It is as I2. This one is also similar to I3. This is same as I3. So this state is called I3. Okay. So I5 state is completed. I2 state is repeated. I3 state is repeated. So stop here. No need to explore. So finally, we have completed the A layer 0 items. Okay, this is the final DFA diagram. Now we'll construct the table. Okay, just count how many terminals. 1, 2, 85. 1, 2, 3, 4, 5. So this state is I0, I1, I2, I3, I4, I5. Then this is plus, this is I dollar T. Okay. So now we'll find out first go to action. First we'll find go to action. So this one is go to action. This one is a go to action. Okay. Just wait. This one is a go to action and this one is a go to action. Okay. So there are 4 go to actions. See, I0 read D goes to 1, I0 read D goes to 1, I0 read T go to I2, I0 read T go to I2. Similarly, I4 read D goes to 5, I4. See, I4 read D goes to I5, I4 read D goes to I5. Goes to I5. Then I4 read T goes to I2, I4 read T goes to I2. Okay, go to actions are completed. Now we'll see the shift action. Okay, shift action. See, this one is shift action, this one is shift action, and this one is shift action. I0 read I goes to 3. 3 means S3. I0 read I goes to 3 means S3. I2 read plus, I2 read plus goes to S4. So I4 read I4 read I goes to S3. Okay, so shift actions are completed. Now we'll see the reduce action. Okay, now we'll see the reduce action. So now we'll see the reduce action. Which one reduce? This one is one reduce because it's a completed production is there, E to T prime T dot. So I2 contains reduce action. I3 is a complete production, reduce action. I5 contains reduce action. I2 also contains reduce action. I3 is also reduce action. Okay. First we'll say I2. First we'll say I2. E to T dot. See, E to T dot, just see the number. E to T dot means in I2, the reduced number is E to T dot means R2. Similarly, in I3, the reduce, just see the number T2I. T2I means R3. Okay. In I5 state, E to T plus C means the reduced number is R1. So in I2, E to T prime means R2, already done. In I3, already done. Okay, now we'll place. Now we'll place the reduce action. In I2, R2. So here we'll place, just I'm erasing this one. This is S4. Okay. S4. So in I2, R2 is also there. R2. In I3, it is R3. In I5, this is R1. Okay. So this is the complete LR0 parsing table. Just see. In I2 state, so in I1 state is the accept action. In I1 state, I1 to $, this is the accept. Actually, oh, sorry. Okay. See, so in I0 to E means I1 state, I1 to $. Now we'll see this is accept or error action. This is accept or error action. So here, what is the rule for means this grammar? This grammar is LR0 or not? This grammar is LR0 or not? First we'll see. What is the rule for LR0? If there is no multiple entries in LR0 parsing table, if there is no multiple entries in LR0 parsing table, then this grammar is LR0. Since there is one multiple entry, see, just this state, I2 state, I2 to plus contains what? Contains two actions, means S4 means shift action as well as R2 means reduce action. Means I2 to plus, this state contains or this box contains multiple actions. This box contains what? Multiple actions. Since this box contains multiple actions, so this grammar is not LR0. So this grammar is not LR0. So is it ambiguous or unambiguous? Because if the grammar is LR0, then we can say this grammar is unambiguous. Since the grammar is not LR0, So this grammar is ambiguous. This grammar is ambiguous. Okay. Now we'll say I want $2. So I want $2 क्या होगा? So I want $2 is just like what? Accept, sorry, it's a error action. Is a error. So I want $2 is just a error action. So this is the method, or this is the means table. This is the construction of table. We can say the grammar is LR0 or not using the construction of LR0 parsing table. Okay. So see, one more important point here. If a grammar is given, the grammar is given, LR0 or not. If a grammar is given, the grammar is LR0 or not. How to know? We can use either the LR0 parsing table, or some shortcut method, or one more shortcut method is also there. One more shortcut method is also there. We can easily know the grammar is LR0 or not without using LR0 parsing table. Without LR0 parsing table. So without LR0 parsing table, how to know that the grammar is LR0 or not? Remember one thing, a grammar is LR0 or not. How to check that? How to check the grammar is LR0 or not? We can check a grammar is LR0 or not either using the LR0 parsing table, or without LR0 parsing table. How to know that a grammar is LR0 or not? Okay, just see the shortcut method. Okay. First conflict is the shift reduce conflict, or it is also called SR conflict. Okay. See, if the production is like, if any state contains the production is like what? A to alpha dot A beta. Means here alpha and beta may be anything, may be terminal or non-terminal. Here alpha and beta may be terminal or non-terminal. Okay. So, and one more production is like beta to gamma dot. Just see, here it means any parser here means first production means a production A to alpha dot A beta. Means in the first production, the parser will scan what? A. The parser will scan the terminal like A. That means it is called shift action. It is called which action? Shift action. Shift action means what? Shift action means it will scan the what? Terminal. That's why it is called shift action. Since it is a completed action, just beta to gamma dot. Here gamma is also, here alpha, beta, gamma, all are may be terminal or may be non-terminal. So here beta to gamma dot, it is a completed action. Since it is a completed action, so it is also called reduced action. So SR conflict means what? It is called shift action. In the first production, it is called shift action. In the second production, it is called reduced action. Means here it is just shift. Here it is just reduced. So that's why it is called SR conflict or shift reduced conflict. Okay. Now we'll see the reduced conflict. What is the meaning of reduced conflict? A to alpha dot and beta to B to gamma dot. Here see it is a completed action. Here it is also a completed action. A to alpha dot and B to gamma dot. So that's why it is called what? Reduced conflict or RR conflict. Remember, These states are called as inadequate states. These states are called as inadequate states. If the grammar contains any one of the conflict, then this grammar is not LR0. Then this grammar is not LR0. Okay, now we'll check how without using LR0 parsing table, how this grammar is LR0 or not. What is the ASR conflict? Here ASR conflict is what? A to alpha dot A beta, then B to gamma dot. So this is called shift action and this is called reduce action. See here, I1 contains only what? Only one prediction. So just skip. Here I2 contains two predictions. Just see. This is called shift action. Here it will scan what? Plot dot plus. Dot plus means here plus is a what? Terminal. Here plus is a terminal. Plus is a terminal means we can say this A equals to, here A equals to plus, A equals to plus. And E to T dot means it is a completed action. See, it is a completed action. Since T dot is a completed action, this is called reduce action. This is called reduce action. Reduce action and this is called shift action. So in I2 state, it is called ASR conflict. In I2 state, this is called ASR conflict in I2 state. Okay, ASR conflict. So using this formula, we can directly know that I2 contains which conflict? ASR conflict or shift reduce conflict. Shift means here, A to alpha dot A beta. Let's see. Here A is T. Here A is T. Here A equals to T. Here A equals to plus. Here beta equals to what? Sorry, A not A. Here alpha. Here alpha equals to T. Here alpha equals to T. Alpha equals this alpha. Alpha equal to T. A equals to plus. Beta equals to E. Then here gamma equals to what? Gamma is equal to, in the reduction production or reduce action, gamma equals to T. Okay, so I2 state contains what? Shift reduce conflict. Similarly, this I2 state also contains what? SR conflict. Okay, because I2 state is here repeated state. Okay, so we can check a grammar is LR0 or not either using the formula, the given formula with the given formula, or using the construction of LR0 parsing table. Okay, so in the next class we'll discuss about some grammar is LR0 or not with some new examples. Okay, thanks for watching.